Okay, so this is section 6-4, factoring special forms. First objective is to factor the difference of two squares. In chapter 5, we multiplied the difference of two squares, so this is just doing it backwards. In this section, we will consider some polynomials that have special forms that make it easy for us to see from the beginning how did they factor. When you have special polynomials, in particular, one that is the difference of two squares, a perfect square polynomial, and the sum or difference of cubes, we will have a factoring formula to memorize that will help us know how to proceed in these. So the difference of two squares, if a and b are real numbers, variables, or algebraic expressions, then a squared minus b squared equals a plus b and a minus b. The difference of the squares of two terms factors is a product of the sum and the difference of those terms. And just keep in mind that the a squared has to be a perfect square. So, for example, if you have 25x squared, you would do the square root of it, and you would get 5x. And since it's a whole number, then it's a perfect square. So you got to keep that in mind as you do these. So, first example, x squared minus 25. So what we're looking at is x squared a perfect square? Which it is, because x times x is x squared. And again, square root of 25 is 5. So that's also a perfect square. So then what we do is we set up our two brackets, x and x, plus and minus, and then the 5 and the 5, because 5 times 5 makes the 25. Okay, so on the next one, same thing. So 9x squared, the square root of 9x squared is 3x. And then the square root of 4y squared is 2y. So that's how that would factor out. Those aren't too tough. You just got to make sure that they are perfect squares for you to go through with them. Okay, so now in this one, if you notice, you got 3x squared and you have a 75, and neither one of those are perfect squares. So your next thought is to see if you can factor something out of them. And what we notice is that they both have a 3. So we can divide them both by a 3. So we're going to divide a 3 out of both of them. So 3x squared divided by 3 is x squared. And then 75 divided by 3 is 25. So once I divide it out, now what I'm going to do is I'm going to try to see if I can break this down farther. So when I say, well, those are both perfect squares like we did on the preceding slide, so we know that it's going to be x and x, plus and minus, and then what times what makes 25, and that's 5 and 5. So that's how that one would factor. So you got to sometimes pull out that special common multiple to help you be able to factor farther. Okay, so on this one I go, well, 25 is a perfect square. And something to do with the exponents is that if you have x to the fourth and you take the square root of x to the fourth, all you're doing basically is cutting them in half. So then that would be x squared. So to be a perfect square with a variable and an exponent, they have to be even exponents. So again, if you have y to the 6, half of y to the 6 is y to the third. So you can go ahead and break those down. So I can do my two parentheses, and I say, okay, the square root of 25 is 5. And then again, x to the fourth would be x squared. So 5x squared on both of them, plus minus. And then 9y to the 6 would be 3y to the third and 3y to the third. And that's how that would factor. Okay, so then I look at this one and I say, well, I can't break apart the 6 because the square root of 6 is not a perfect square. So I can't break that apart. So then again, the next step is to look for common multiples. And I say, well, they both have a 6, so I can pull a 6 out. And then when I factor it, I get x squared minus y squared. And then I say, well, I can go farther because those squares are perfect squares. So I'm going to go 6, set up my 2 parentheses, x and x, plus and minus, y and y. And then there's my answer for that one. Okay, x to the 4th minus 1. Okay, so again, the square root of x to the 4th is x squared. And then you got to be careful, the square root of 1 is 1. So that one can be broke down. So again, I do my 2 parentheses and I say x squared plus minus 1 and 1. But then I go to type that into my math lab and it says you're not quite done because you got to factor further. So out of those two, which one can we factor farther? And hopefully you're saying to yourself, you can factor that one farther. So we got to take that one step farther. So we're going to bring down this x squared plus 1. And on this x squared minus 1, we're going to break it down to 2 parentheses. We're going to go x and x, plus and minus, and 1 and 1. So you're asking yourself, why can't you break down x squared plus 1 farther? Well, the reason that you can't break it down any farther is this plus sign. So this makes it unfactorable. So you can't factor that one any farther. So then this would be my answer. It has to be a minus for you to be able to factor that any farther. So make sure you're paying attention to those signs. Okay? All right, next one. Okay, now I got a polynomial with 4 terms. So what we've learned with 4 terms is you go ahead and you group it. So I'm going to draw parentheses around the first 2 and the back 2. And so on the first part, I say to myself, what can I pull out of there? Well, they both have an x squared, so I'm going to pull an x squared out. So here's my x squared. Now let's see. X to the 3rd divided by x squared is x. 3x squared divided by x squared is just 3. So that's how the first part factors. The second part, remember what we talked about is if it starts with a negative, you factor out a negative first. So what I'm going to do is I'm going to pull out a negative 9. They're both, I can divide 9 by both of them. So negative 9x divided by negative 9 is x. Negative 27 divided by negative 9 is positive 3. I like when I see that because remember the goal is for those two to be the same. So once those two are the same, I can say, well, my answer is going to be x squared minus 9. And then that common one, which is x plus 3. But again, if I type that in my math lab, it's going to say, no, you're not quite right. Because remember, you can factor this one even farther. So this is when it gets tricky, and you have to make sure that you factor it all the way. So when I factor this one, I do my 2 parentheses. And I say, well, that's x and x, plus and minus. And then what times what makes 9? 3 and 3. And then I can type in then I bring down that other x plus 3 from right there. Now that is your answer, but if you want to write it a little simplified, you can say that it's going to be x plus 3 quantity squared, because there's 2 of them, and then x minus 3 as your final answer. I think my math lab would take either one of those answers. So, all right, let's go to the next part. Okay, objective 2, factoring perfect squares. Sometimes, when I'm factoring these, I don't always recognize these, but so if you just go to factor them like what we learned, and I think it was lesson 2, you'll get the same answer. So that's the good part. So factoring special forms. These are the special forms. So, if you look at these, you notice it's a plus b quantity squared. So if you take a, b, and you multiply it by 2, you get that middle term. Again, if you go ahead and you just factor these, and then you notice that they're perfect square trinomials, then you're all set. It's no big deal. So if I was to go ahead and I factor these, what I would do is I would make my 2 parentheses, and I would say x and x, and I say plus and plus, and And then what times what makes 25 that adds up to be 10? 5 and 5. So then that's a perfect square trinomial. Now, basically what they were saying in that last part is that if you take the square root of the back one, and then you take that and you multiply by 2, and that gives you your middle term, then you can break it down like that. So again, like you would do square root of 36 equals 6. Then if you take 6 times 2 and you get that middle term, then you can go ahead and factor it. So then if I look at this, I go, well, that's going to be x, whatever that sign is, minus this quantity squared. But again, you can do your two parentheses and you say x and x minus minus what times what makes 36 that adds up to be 12, and that's 6 and 6, which gives you the same answer. So these are ones that you can do a couple different ways and end up with the same answer. So whatever works for you. Okay, so this one gets a little bit more complicated. So maybe I'm going to try that trick to see if they're perfect squares. So I say, okay, well, what times what makes 16? I say square root of 16. I say, well, that's 4. The square root of 25 is 5. If I multiply those two together and multiply by 2, do I get that middle term? And I do. So again, I got that middle term. So I can go ahead and I can say, okay, here's my two parentheses, 4x for the 16, 4x for the 16. Shoot, wrong button. Sorry about that. And then I'm going to go minus, minus, and then I'm going to do the 5y. And again, 4x times 5y is 20xy. That makes 20xy. So together that makes the 40xy. So then my final answer is 4x minus 5y quantity squared. Okay, the factoring the sum or difference of two cubes. This is just patterns. You got to look for the patterns that they're giving us. And you got to understand what a cube is. And a cube is like if you take a number and you cube it, you're saying 3 times 3 times 3 is 27. So if I'm looking for the cube root of 27, I know that it's 3 because 3 times 3 times 3 is 27. Or the cube root of x to the third is x because x times x times x is x cubed. So these are, you just got to kind of think about threes this time. Okay, so these are your patterns that you want to make sure that you understand and you write down, put them on a note card or something. But if you notice the pattern, this is a plus, the first one is a plus, and then the second one's a minus. Same thing down here. If it's a minus, the first one's a minus, the second one's a plus. So they kind of follow the same patterns. And then where you have a cubed, you have a plus b. So that a value is the cube root of a to the third, which is a. And same thing with a b. So you're going to be thinking about cube roots in this one. Okay, so for example 1, x to the third plus 8. So here's my scratch work, and I'm saying to myself, the cube root of x to the third is x. So that's going to be my a value in my pattern. And then the second one, the cube root of 8, and I'm saying, okay, what times what times what 3 times equals 8, and that's 2. 2 times 2 times 2 is 8. So that's going to be my b value in my pattern. Okay, so the next step is I figure out which pattern I got to use. Do I use pattern 1 or do I use pattern 2? And x cubed plus 8, it looks like I'm going to use pattern 1 because of the plus side. So the pattern says a cubed plus b cubed is going to equal a plus b. Then a squared minus ab plus b squared. Okay, so now I'm going to take those values of a and b, and I'm just going to plug them in. So x cubed plus 8 is going to be x plus 2. Now I usually write this out and then I kind of simplify it. So I'm going to say x squared minus x times 2 times 2 squared. So now my final answer, I'll use a different color here, is going to be x plus 2, x squared, x times 2 is 2x. Oh, that was a plus sign. Plus 4. So then there's my final answer. And you're never going to be able to factor any farther on these. That's the good part of those. Okay, so here's another one. So what I'm doing is I'm thinking to myself, the cube root of 8y to the third is 2y. And the cube root of 27 is going to be 3. So that's going to be my a value. And that's going to be my b value. Okay. Next step is I got to figure out which pattern. So because it's a minus right here, I'm going to use the a cubed minus b cubed pattern. So it's going to be a minus b, a squared plus ab plus b squared. Okay. So now I'm just going to plug in my values. So I'm going to say, okay, a is 2y and b is 3. So I'm going to say 2y minus 3. This one I got to be really super careful. 2y squared plus 2y times 3 plus 3 squared. Okay, so 2y minus 3. 2y times 2y is 4y squared. That's the area that I see the most mistakes that students make, is they forget to make that 4y squared. They'll put it as 2y squared. 2 times 3 is 6y, and then 3 squared is 9. So then that's my final answer for that one. They're kind of fun. All right, so let's try this one. That's my dryer going off, but we'll keep going. So now we're going to go, okay, so we're going to get the cube root of x cubed y cubed, which is going to be xy. And then the cube root of 64. And that's just going to be 4 times 4 times 4 makes 64. It just takes practice to get to know those. So you might have to use your calculator to help you come up with some of those. Okay? And if you need help finding a special button on your calculator to help you do that, just let me know and I'll help you. Just give me a text. All right, so plus. So I'm going to use a plus b. Then a squared minus ab plus b squared. Don't worry about if I'm writing in capital letters versus small letters. They all mean the same thing. Okay, so I'm going to plug it in now. So I'm going to say xy plus 4. And then this one I got to be careful again. Xy squared minus xy times 4 plus 4 squared. Okay, so I just got to clean it up and I'll get my final answer. So xy plus 4. Xy squared, so that's x squared times y squared. So be careful when you write that one out. Because remember, you got to share the exponent. And then xy times 4 is just 4xy. And then 4 squared is 16. So then there's my answer for that one. Okay, so that's the end of lesson 6-4. If you have any questions or concerns, please don't hesitate to send me a text on how to do a problem or any questions on this video. Okay, good luck, and I'll see you in the next video.